Good afternoon, everybody. So today we're going to be talking about surface area or starting surface area. Today we're going to specifically talk about prisms and cylinders. And in the next video, we'll talk about cones and pyramids, and they kind of go together. So just a couple of things here is that when we talk about surface area, we're talking about the area of all of the faces or surfaces of a shape. So if I think about something like a trapezoidal prism where I've got two things we call bases, which are these trapezoids here, and then there's one in the back that's kind of hard to see there. We also have these what we call lateral faces along the sides, and here there's one there, one there, one there, and then one hiding down here at the bottom. So for something like a trapezoidal prism, we've got 6 separate faces, the 2 bases and then the rectangles that go around the shape. Prisms are pretty much all going to be that way. They're going to have 2 bases, and then the rest are going to be rectangles. The bases always have to be the same, but they might be things like squares, they might be octagons, they might be triangles, whatever it is. And then for a cylinder, it's kind of similar to a prism in that it's got 2 bases. In this case, those bases are both circles. And then it's got this curved surface, which we'll also call the lateral face in this one. But this curved surface that wraps all the way around that shape. And we'll talk about how to deal with that in a little bit here. So when we're finding surface area, one thing I really want everybody to kind of be aware of is that they're not hard problems. What they are is long problems that are easy to make little mistakes on. And so your organization is kind of the key here. When you're doing these, I want you to draw each of the different faces. Make sure you're talking about if it has duplicates. So if there's 2 bases, note that. If all 5 rectangles are the same, make a note of that. And make sure you include the measurements, the length, the width, the height, the apothem, whatever you need. Then just find the area of each one and add up the totals. Make sure you are showing your work, though. It is so easy to make mistakes on these problems if we're not being careful and showing everything. So we're going to do 3 examples here, 2 prisms, and then we'll get to a cylinder. So for this first one, this shape here has 3 different shapes on it. And I'm going to color code here as much as I can. So this front and this back are the same. We could call those our bases in this case. It really doesn't make much difference. So this has a rectangle that is 3 tall and 6 wide. And I'm just going to make a note here that there are 2 of them. Then I can get rid of those. We'll switch over to a different color here. If we do this side, there's one there. There's another one that's the exact same there. And these are 3 tall by 8 long. And there's 2 of those. And then after that, we've got the top and the bottom of this box. So we have a shape up here. I'll do that in blue. We have a shape up here. And we have a shape down here. And those are 6 by 8. So I'll do 6 there, 8 there, and just make a note that there are 2 of those. So I'm drawing all my shapes out. I'm aware of what they are. They're all rectangles. Now I can go back and start to find them. So I'm just going to write down my area formula. It's base times height, which gives me 18 for this one. For this one, it's also base times height. 8 times 3, that one's 24. And then for my last one, again, it's a rectangle. So base times height. And this one is 48. Now, those are just individual shapes. I haven't actually done the 2 of them yet. I like to do it at the end, but that is really entirely up to you. So what I do now that I found each individual shape is I go through and I just combine them all together. So I will write, I need 2 of my 18s and 2 of my 24s and 2 of my 48s. And I will usually just let a calculator handle that, right? So if I've got Desmos opened up, let's do the scientific version here. I'd have 2 times 18 plus 2 times 24 plus 2 times 48. And I know then I've got my total there is 180 square meters. In this case, it's meters. So I just find all the shapes and I add them up. That's surface area. None of those were hard. It was a rectangle, a rectangle, a rectangle, add them all up. But if we're not being careful, we can make mistakes pretty easily. Okay, next up, we've got something like this. This is a hexagonal prism. If you look at these shapes here, you've got hexagons at either end. So there's a hexagon, exactly the same. And then there are 6 rectangles. So I went ahead and drew those out so I could make them accurate ahead of time. But this is what I've got. And I'll just go ahead and start finding all of my areas. So for my hexagons, I know my area formula is 1/2 times A, which in this case is the 7, times S, which is 8.1, times N, which is 6. I will plug all of that into my calculator. 1/2 times 7 times, go away, times 8.1 times 6, and that's 170.1. And then I'll come over here. This one's just a rectangle, so it's 21 times 8.1. And I'll do that. And also 170.1. That is just a coincidence for this particular shape. That will not happen most of the time, for sure. And then I'm just going to add them up. I know I've got 2 of my bases plus 6 of my rectangles. And I'll add those all together. I'm going to show it like this, even though there's 8 shapes that have that same area, because normally there wouldn't be. So I'm adding 2 of those, plus 6 of those, and I get 1,360.8. in square meters. So again, found the area of a trapezoid, or of a hexagon, found the area of a rectangle, multiplied by however many I had, and added them together. Okay, now the last one's a little trickier. We've got a cylinder. So a cylinder has 2 circles, but then also this curved surface in there. And what I want you always thinking about with a cylinder is, what does that look like if I unwrap it? Well, my curved surface is just going to be a rectangle if I unwrapped it. Just like how all the other prisms had rectangles as their sides, so does this one. The real question here is, how long is that rectangle? And we got to think, in our cylinder, that length of that rectangle matches up with the distance around the cylinder, which we call the circumference. So my length here is just 2 pi r. There's my radius there as well. And so if we look at this, I'm going to come back to this in a second, but the areas of our different shapes here, each circle has an area of pi r squared, and my rectangle has a base of 2 pi r and a height of h, so 2 pi r times h. If I put all that together, there are 2 pi r squared, so 2 circles, plus a rectangle. The 2 circles give me this 2 pi r squared. The rectangle gives me this 2 pi r h. So somewhere in your notes, you should definitely have that formula written down. And I like to make a note that this 2 pi r squared is because there are 2 circles, and this 2 pi r h is the rectangle. So now, let's go ahead and go back to this. I'm going to get rid of this picture now. And in this case, since we have that nice formula, I'm just going to show you how to do that with just the formula. I'm going to write it down. Area, or surface area, equals 2 pi r squared plus 2 pi r h. And I'm just going to start plugging in the numbers. 2 times pi. Now my radius is not 10. My radius is half of that. That's 5, because the 10 is my diameter. Plus 2 times pi times 5, and my height is 12. And I could go through that, and I could simplify it using all my order of operations and everything I learned in Algebra 1, or pre-algebra, or whatever you learn that. But I can also utilize some technology here. I go 2 pi times 5 squared plus 2 pi times 5 times Was it 20? 12. And get my total that way. So if we have a formula like we do for a cylinder, it's a really nice option just to type it all in and say, okay, it's 534.1. Alternately, even with my calculator, one thing I could do here is I could start doing this thing in terms of pi. So if I had 2 times pi times 5 squared, I can also just type in the pieces without the pi. So 2 times 5 squared gives me 50. And then I could also do 2 times 5 times 12, which is 120. And so between those two, I have 170 pi's, 170 in terms of pi. And that's also an option. If you leave out the pi in the calculator, you can put the pi back in at the end as just pi and leave it in terms of pi. So for cylinders, I really like just using that formula. But don't forget, you can always split it up as long as you remember the length of that rectangle is the circumference of the circle.